So we're all consuming more and more and more internet traffic very quickly, and data centers are getting the brunt of that. We don't often think about, though, the impact that data centers have on the environment. And Hamid, you've created a technology that significantly reduces the environmental footprint of data centers by way of your quantum dot technology. How does that work for us?
Our technology is based on providing high capacity and power efficiency through physics. It's a technology we've created inside data centers today. There are fiber optics connecting the source of data and the destination of the data. And these fiber optics usually carry one color of light. And that color of light you can put information on it. What we've created is a source of light that can generate multiple colors of light simultaneously using quantum physics.
And so what you describe is the analogy to a highway system and buildings in a city. You've created a stacked highway that's as many as 40 lanes high using your technology. It's also, though, using a lot less power. So what's the impact on the power consumption?
We have, apart from our light source, which has these many lanes of highway, as you mentioned, we have miniaturized the rest of the components using our silicon photonics capability. So these are very, very tiny devices, and they are very close to each other, so they consume very little power to transmit information between each other. So everything will be instantaneous using our technology. One other element is, if you look at the future of our economy, is really going to be based on a lot of AI and machine learning. These elements consume a lot of bandwidth inside the data center. For every kilobit of data that you receive from your Facebook page or LinkedIn or other applications you use, they generate 1,000 times of that in terms of traffic inside the data center.
What does the roadmap look like for your technology in terms of the capacity to move more data more quickly?
Yeah. The next step for us is to look at servers. Inside servers today, you have the processor, memory, and storage. And this is a very monolithic architecture with electrical connections between them. And it's not scalable. What we do with our next generation technology is to try to move these into separate racks and have them connected together using our technology so they can scale on their own. If you needed more memory, you add more memory to the rack. You don't have to buy a new server. So we are completely backward compatible to all the electrical interfaces that come from existing equipment. Today, all the industry has been standardized around a certain form factor, and we fit within that form factor. But what you could do inside is you can build technologies that reduce the power consumption and